We have the slides. Okay, so I will talk today for about 40-45 minutes, focusing on the economic importance of AI, trying to demystify and simplify some of these things, and then talk about opportunities for Tunisia, for North Africa in general, in my opinion. I have a lot of slides. We'll make the slides available. I will skip through many of them, but if you're interested, please, we'll leave about 15 minutes for questions and answers at the end. So hopefully that will be enough. Is this advancing? I think we're very far from... Whoa. I think we have a lot of delay. Okay. All right, as mentioned, I had a lot of experience both with making AI work in large companies, making AI work for startups, making AI work for a lot of companies that we work with in my company, Open Insights. Today I'm the inaugural director of the Institute for Experiential AI. We'll talk a little bit about that. Let me see if this will advance. Wait. Yeah? Okay. All right, this will go very slowly if the signal is too slow. So, AI, you see it everywhere nowadays, on iPhones, through Apple for face recognition. You see it in applications like, can I see if there's a brain disorder? This is a startup we worked with. You put on a headset and it figures out through tests whether there's a problem and what the problem is. Here's another startup where for Parkinson's disease, the AI can actually examine the patient's movement and measure the progression of the disease so that you can do digital health basically more frequently, more reliably, and remotely, more convenient for the patient. Teaching music with AI, I'm going to skip this one. You can use it in industry, for example, what we call XR, which is augmented reality or virtual reality, where you can examine what's happening inside a machine by looking at it. Drone delivery. I think it's not loading the video here. Video cannot be loaded. Okay. Not sure why. But what I wanted to show you here was actually how it works. So we give up on the videos? Is that? That's okay, we can. No video. Okay, so AI, very quickly. AI has a very simple definition. We're not going to spend time on it, but it's a very problematic definition. It's defined as using computers to simulate human intelligence. The big problem is, until today, for the past 100 years, we have not been able to define what we mean by human intelligence. Machine learning, despite the fact that we have now AI programs that can play chess better than the best humans, play Jeopardy better than the best humans, we still are struggling to understand intelligence and to make machines even have simple reasoning, like common sense reasoning. This is not, okay. Machine learning is a subset of AI, which is about saying, okay, we don't know how humans do it. Can we use the data, which we have a lot of data, to basically decide what is the right action to do under the right data measurements or attributes. In the past, and we're going through this now again, we've had two big hype cycles, right? A hype cycle means people expect too much of AI. They think it will change the world. They think it will take away jobs. They think all of this. It happened in the mid-1970s, and then was followed by what we call an AI winter. AI winter means everybody stops funding AI, nobody does work in it, etc. The same thing happened again after neural networks came through with the second AI winter in the 1990s. So by the time I was graduating with my PhD in AI and machine learning, we were starting a second AI winter. Fortunately, or unfortunately, we are going through the same problem now. A lot of hype, a lot of claims about AI. There's this guy, Elon Musk. He has been predicting autonomous, fully automated autonomous driving for every year for the past 5-6 years. Hasn't happened yet. Now he is predicting that next year we will have a machine that's smarter than the smartest human. Absolutely will not happen. The current technology cannot even get there. But unfortunately, these things don't help the field, they actually hurt the field. The US was afraid of something called, back in the 90s, of something called the Japanese fifth generation systems. Nothing happened. Now we are worried about China 2030, which seems to be much more serious than the Japanese threat back then. Everybody's saying we're going to be jobless and brainless, but we will talk about this. I think that is far from reality. If we can advance, yeah. Now, machine learning has survived both AI winters. Why? Not because we have better algorithms in AI, but because we have a lot more data. I don't know if this is advancing. Yeah. Okay. So data is what basically advanced the field over the past 20 years, 30 years, primarily because of digitization. And we're going to come back to this theme. Okay, so very quick summary here. AI is the overall field. Machine learning is a subset of AI. And a subset of machine learning is generative models, which we will focus on and talk about advances in generative AI, why it's important, etc. Now, while this is the breakdown, if you look at applied machine learning, in the real world, supervised learning, which is when I give you data that is labeled with the right outcome for every data point, that is the biggest share of applied programs out there. This is classical predictive AI. Second comes unsupervised learning, which is when we use the data to kind of group it and cluster it to find similarities. That also has applications. Gen AI, even though it has a lot of attention, has really very few real applications out there. And then there's a whole bunch of learning algorithms that you probably never hear about unless you're doing research. It's important to mention that even though people talk about the machines doing all the learning, they need a lot of human intervention, human guidance, constant course correction. All working AI is dependent on human intervention here. So I'm going to talk about 7 secrets of making AI work. The first secret in the real world. The first secret is you want to make the problem as narrow as possible. This is the opposite of ChatGPT, the opposite of what you're seeing right now with these very large models. You want to make it as narrow as possible where you can have complete knowledge of the domain. Is that possible? Yes. If you're playing chess, you can have complete knowledge of the world because all you need are the rules. If you're in a controlled setting, a factory, or you're doing a lot of manual kind of programming or data processing, all of those are controlled situations where it's possible to have essentially near complete knowledge. Unexpected things don't happen frequently in those environments, and that's where it works. So how did this manifest itself? Let's look at one of the big, what we call challenge problems in AI, machine vision. Can I give you an image? Can you tell me what's in the image? Today, there is no computer algorithm that can do this, including all of generative AI. Understanding what's inside an image is a very hard problem until today. For 40 years, the US alone spent hundreds of billions of dollars on the research. How did we solve it? And this is a joke in the machine vision community. Well, we solved it. You know, if I show you this image here, it's a hard machine vision problem because you have occlusion, you don't see the full objects, different orientation, different lighting. But the solution really was to put a barcode on everything. And the joke in the machine vision research community was, well, we solved machine vision, we will put barcodes on everything and everyone, and that solves the problem. Of course, this has nothing to do with how humans see the world. It's a completely different way of working. I don't know, this thing is not, okay. So no relation to how humans see the world, and that's important to keep in mind. I'm not sure what I can do to make this go faster, but okay. You may have heard in the US, Amazon launched a bunch of stores a few years back called Amazon Go. So you enter the store, you pick up items, you don't talk to anyone, and you leave. And it figures out how much to make you pay, and it charges your account. If you're like me as an engineer, you enter it and you look at the ceiling and you see all these devices pointing down, trying to figure out which, chocolate bar you picked up, which item you picked up. And I always wondered, does it make sense? And the answer is no. In fact, recently, Amazon decided they're going to shut down all these stores because I think economically they don't make sense. Of course, their reasoning is they said the customers didn't like them as much, but that's not quite true. So, secret 2, you need to make sure you have a business case and you have buy-in from different parts of the organization, including people like finance, verifying your claimed return on investment or ROI. And if you don't do that, it doesn't work. Now, human in the loop is very important for AI. This is something that the big companies don't talk about. So number 1, data is super essential. You have to collect events, outcomes, and context. And intervention is essential. And this is the part they don't talk about at all. So if you look at the companies who do a lot of AI, we can use Google. We can use Google as an example. They understand this very well. So what do? They actually capture every bit of detail of human intervention. So how does human intervention happen in Google? At the core of the Google search engine is something called MLR. Stands for Machine Learned Relevance. That is the engine that decides, based on your 2.5 keyword queries, what are the results that are most important or most relevant. That engine is retrained 3 to 4 times a day, every day, based on feedback from teams who are dedicated just to collect the data, the feedback. It says, move this result down, move this result up. This is a meme, it means something completely different, etc. This is happening 3 to 4 times a day, every day, for the past 20 years, based on feedback of about 20 to 25,000 people. Some are employees, some are contractors, some are crowdsourced, just to give it the feedback. So it's very important to do that human intervention. This is happening a lot in generative AI. If you look recently, this is Jamie Dimon, who's the CEO of the biggest bank in the US, JP Morgan. In his letter to investors, he talked about data 27 times, talked about 300 use cases of AI. In 2024, he talked about AI being like the steam engine and having 400 use cases of AI at the bank. So the big banks understand it. There are many applications of AI and generative AI in banking, in financial services, in insurance. I listed some of them here. I'm not going to go through them. We will go through one case study a bit later in this presentation. Uh, so, I don't know if you're advancing it manually or you need to basically leverage this technology, but use it with care. Fintech is about kind of factoring these functions and embedding them in the economy. And a lot of that is redefining banking and how we do banking. This is why the banks care about this. As I advance. So if you look at things you have to worry about, fairness and bias. If you show it data that is one-sided or does not represent the world correctly, it will learn things that you don't want it to learn. The algorithms have very little or no reasoning, so modeling complex decisions is still a very hard problem. It's not solvable, and that's a big problem. Advanced technology, of course, can represent deep invasion of privacy and many bad things. We'll talk about some of them. And finally, Gen AI, there's not a very good understanding of how it works and why it works. But there is a very good understanding of the fact that when you feed the algorithm something it hasn't seen before, we completely know that the answer could be totally random. It's very unstable. So very unpredictable answer if it faces a situation that is not in the training data, which is a big problem for Gen AI. Good training data is extremely expensive to get. Having that data labeled with the right outcomes is even more expensive. Just collecting and managing the raw data is a challenge for most companies. They can't do it. And this is why you're seeing only some of the big companies doing AI. Most other companies, they want to do AI, but they can't because they're not collecting a lot of the valuable data they have. I'm going to skip forward. Sorry. Oh, this is going backwards. Okay. Secret number 3, you have to capture data at high granularity. So the kind of data we collect when we do data for insights and data for summarization and data for human consumption is completely different than the data you need for algorithms. And that is why another thing where many companies miss out on this, very few companies, Google is a good example, OpenAI is a good example, Microsoft now, kind of know how to collect the data, and a lot of the data is unstructured, so it's not the usual structured database data we're used to, and therefore very hard to make work. So, in summary, data is critical. Without proper data, there is no AI, and a lot of unstructured data is very important. Both of those are challenges today to the typical company, and I'll come back to why those are opportunities now. Experiential AI. I run the Institute for Experiential AI. What is experiential AI? It is our code word for AI with a human in the loop. So we believe human intervention is a must, and human intervention is a great way of collecting intellectual property, of collecting know-how, and making things work. Let's see if it wants to advance or not. Yeah, is it happening? Yeah, sorry, this advancing is lagging by a lot. ChatGPT, you all heard about it. The reason you all heard about it, of course, is it went from 0 to 100 million users in about 2 months. It took Google Translate and Uber something like 70 months to get there. If you look at reports from, this is advancing too much. If you look at reports from McKinsey and others, they say the impact on the economy is in the trillions. I won't go into the details, but I'll talk in general about what this means. So, what is the impact of this technology? On the knowledge economy, there's many estimates, anywhere from 15 to 80% acceleration of tasks, right? So what is this knowledge economy? And this is, by the way, very significant What is the size of the knowledge economy? According to the UN, it ranges from 19 to 30% of the economy globally. In richer countries in Europe and in the US, that range is somewhere around, in the US it's about 51% of the US economy is knowledge economy, which means even if you could accelerate 1%, right? Not just 15 to 80%, but just 1% of half the US economy, that is huge. Now I say accelerate, but not automate. Automation is not there. The human in the loop is absolutely essential. You have to check the output of these algorithms. You have to approve it and modify it. And that is where the opportunity is that we'll come back to later. So I get asked the question a lot, will AI replace my job? My answer is, AI will not replace your job, but a human using AI will definitely replace your job if you're not using it. So that's why it's important to figure out how to use this AI, because it gives you a big advantage in accelerating work. There's many applications in many areas. I'm going to skip through them because we don't have the time. But in legal, in film and media, in medical, we work a lot in healthcare, in life sciences, and so forth. Gaming, etc. So many applications of generative AI. We will look at a few of these. So bottom line, this is all built on very large, deep neural networks. We call them large language models. If you're training on language, billions to trillions of weights. They serve as glorified autocomplete. So it's really just autocomplete technology. Does not understand what's going on. We call them stochastic parrots in the literature. Parrots because they don't understand what they're saying. Stochastic because there's randomness in how they work. But in the knowledge economy, they make a big contribution. So with that, I want to shift to, reminder that, of course, human intervention is still extremely important, even though the companies don't talk about it. So after you train these big models, and you spend so much energy training them, you still need humans to kind of adjust the model. It's called fine-tuning in the industry. So let's talk about the quick evolution. What happened over the past year since ChatGPT got the attention of a lot of people? Well, we went from fascination and kind of nice demos to real questions like, does this work? How well does it work? How much productivity does it produce? Is there a real ROI or not? And I'll show you some examples of this. So let's talk about, for example, Microsoft Copilot for Code. Microsoft bought a firm called GitHub. GitHub was used by the open source community to manage code bases, to share code, to share data. That gave Microsoft access to hundreds of millions of programs. And I thought, you know, teaching a machine to do programming is easier than language, than human language, natural language. And will this replace programmers? It turns out the answer is very interesting. Teaching code is a lot harder because in natural language, I can say something, you know, in 20 different ways and you can still understand me. In code, if you do some variations, the program could not work. So the question is how much. We worked with some firms to measure how much speed up you get. And this is one of the lessons that's important. If you're a very good programmer, you get about 60 to 80% speed up. So let's call it 70%. So if you're a good programmer, your market value increases by 70% because you are 70% more productive if you use the code. If you are not so good programmer, it's actually a negative. It will take you longer to look at what the machine produces, figure out how to debug it, and then rebuild it, than to do it by yourself. So you actually end up being at a disadvantage. What does this mean? This means skill is now even more important. So if you don't have the right skills for programming, you will have trouble getting a job as a programmer. And the gap between you and those who have the skill is much larger. This is also happening at company levels, and we'll talk about some of that. There's examples of training like Khan Academy. Training and tutoring is a good domain for this generative AI because you know what the answer should be, right? And there are no kind of unpredictable situations. That's an ideal situation for the technology, by the way, which is why it contributes so much to the knowledge economy. All right, so I'm going to use an example here. This is, the name is Gen AI, which is cute. This was done by Virgin Cruises. I'm going to ask us to play the video, hopefully. Oh, okay, it's working. So let's look at this video for 2 minutes. Do we have sound? No sound? Okay. All right, so this is a campaign run by Virgin Cruises, where they had Jennifer Lopez kind of do the work. But if the video were to play, which maybe it will and maybe it will not, when we tested it, it was working. Unfortunately, now it's not. The videos produced are not Jennifer Lopez.
Jennifer Lopez, Chief Celebration Officer of Virgin Voyages, here to invite you to celebrate. So come, celebrate
your anniversary, your birthday, or just generally being fabulous.
Really, Kyle?
It's good, right?
Gen AI is supposed to be inviting people to Virgin Voyages, not doing whatever that was. You know, just give me that.
As I was saying, why not celebrate on an award-winning voyage with Michelin-starred, chef-curated menus,
World-class destinations, award-winning...
Boring! I'll hop in there. I'll hop right in that suit.
so supple.
I can't watch this. Give it to me. There's no kids here. That's all you need to know.
No kids!
Oh, can I live there?
Gen AI. Invite your crew to voyage. Create your custom invite at virginvoyages.com.
It's not just a yacht, it's a super yacht.
Can we go to the slides? Yeah. Okay, so why is this? We don't want to play this. No, we want to advance the slide. All right, so what happened here is they used the technology, and this is, by the way, generative AI. Back one. Oh, this is the beginning. Okay. So they use this to basically say, if you buy a ticket for a cruise, you can generate a customized application by Jennifer Lopez to send to your friends or your family to join you. They were able to sell about 1,000 tickets additional just by allowing people to do this. Is this generative AI? Absolutely. They use generative voice to change your voice to Jennifer Lopez's voice. They use generative video to change your image to her image on the video. Okay? Now, that was very effective. It was done at scale, and it worked extremely well. But in some places, like imagine my name or some Arabic name, if the AI cannot pronounce the name, they had tricks like Jennifer Lopez would say, "Hello, sailor," instead of "Hello, your name," right? So that's an example of bias in the training. If we go to the next slide, yep. So this all, of course, enables bad uses, right? It's not only good uses for marketing and so forth. You could use it for fraud, impersonation, coming up with human likeness. If you go to the next slide, please. I think I'm going to give up on this slide advance. You could come up with fictional, you can ask DALL-E to give you a picture of an astronaut riding a horse. We all look at the image, we all say, oh, this is fiction, it's funny, right? But what happens if these mashups become more interesting and less obvious, and they're no longer fiction. So, was the Pope really wearing these, outrageous outfits? The answer is no. But the ability to generate these images was very, very, very easy. Same here. Was Trump arrested by police in the streets of New York? Some of us wish he was, but it didn't happen. Yet, this was very easy to generate, almost a few seconds of work. And you can, of course, do videos and so forth. So, another secret of making it work is you got to think through the responsible use of AI. And it has to be a responsible AI by design, and you have to have a risk assessment process to understand all the hidden things you didn't think about when you implement the AI, because that could result in a lot of damage. Advancing further, okay. So, major developments in last year. People suddenly discovered that, hey, smaller LLMs are more effective. So, if you know about GPT, ChatGPT was first launched on GPT 3.0, which was about 175 billion parameters. After 2020, OpenAI stopped being open, so they wouldn't tell us what's in GPT 3.5, what's in GPT 4.0. We think 3.5 is about 500 billion parameters, weights. We think 4.0 is about between 1.3 and 1.7 trillion. And there was this obsession with bigger and bigger and bigger models. My model speaks 60 languages, 80 languages, knows every field of science. You don't need those in most applications. In fact, the smaller LLMs can be much, much better, and we'll walk through a case study of that. Now, the big companies are discovering that, hey, smaller LLMs are actually better, and Microsoft and others are beginning to talk about SLMs for small language models. Next slide. Okay. So let's do a very quick case study and head towards the end here. Here's a case study from Bloomberg. So Bloomberg decided to build their own LLM. They did a 50 billion parameter model. Why did they build it? They built it to address several tasks. So what are these tasks? The first task was, let's see if it advances. Sorry, but it's taking its time advancing slides. Okay. First task is, I feed it a news article, and I want it to produce a headline. So, home prices see biggest drop in 15 years is a summary of what's in the article. And remember, Bloomberg does this many thousand times a day for news pieces. Same thing here, more examples of outputs. Next, next. So you get the idea. I give it a news article, it gives me an answer. Then they took the same model, and it did this very, very well. It beat all the benchmarks, okay? Then they said, okay, why don't we use this to state a question in English and produce what's called BQL, Bloomberg Query Language, which is a type of SQL. And sure enough, it did very, very well with this too. In fact, this domain-specific language that they developed to enable all this allowed them to do many other applications, like sentiment analysis. Is an article positive or negative? Can I recognize who, what, when, where, what the event is? Answering financial questions, summarization, and the headline generation that we talked about. So all of these worked. They worked really well. Amazing results. They were very proud of it. Why did they build a 50 billion model? Which, by the way, 50 billion is not considered too large. Here's the answer. The management gave the team about $3.5 million of compute and said, see what you can build with $3 million of compute. They did lookups to see what is the biggest model they can afford with $3 million for computing on the cloud, and they found that 50 billion was the number. Now here's why this is interesting to us. Shortly after that, a small company called Stochastic AI built a model called X-Finance. It did just as well as Bloomberg GPT, sometimes better. They used the 13 billion model from Llama. Llama is from Facebook, from Meta. They give you a free open source license, and the license can be used commercially, by the way, so it's a good thing. But what is interesting is their total compute budget was not $3 million, it was $1,000. So for $1,000, using a pre-trained model and fine-tuning it for the domain, they could get the same results. 25% of the size, 1,000 times cheaper, much easier to maintain, much more stable, because it's smaller. So whenever somebody tells you larger models are better, they're not telling you the truth, and we can discuss this. So that reminds us of secret number 2, which is, do you have the ROI worked out? Do you really understand the cost benefit of doing all this? What else has happened? Ease of use and integration with applications. There's many ways of simplifying it. GPT-4o is now truly multimodal, so which means you can give it text and you can give it images, and it can give you answers based on both, which is also new. And it seems to be working well. So what's an example of somebody doing this very well? I like the example of Adobe. This is Photoshop. They created this thing called Firefly. So what does Firefly do? You basically show an image and you highlight parts of it and you say, adjust it for me. And the AI does the work. Why do I like this? Because it was a private large language model. It was trained on images completely owned by Adobe. So over 40 years, they built a big image library, and they only used images they completely own. So there's no IP rights, which means all the users are indemnified. Nobody can come after you and say this is illegal, because Adobe is giving you all the rights for it. And the way it works is you can pick an image, you can pick part of the image, you can say, insert a classic car here, put a reflecting pond of water, make a cloud that's in the shape of the car, and you do this just by pointing and clicking, and it's all protected from an IP perspective, right? Because they did it well. So secret 6, of course, is incremental and continuous is the way to go. So small steps over a long time. Remember Google, 20 years of refinement. It didn't happen overnight. So other things is robustness, mitigating against errors. You hear about RAG, for retrieval augmented generation, which means we recognize the machine doesn't generate the right stuff. We can add lookups. We can readjust the prompt and focus it on its answers. A good example of this is the new AI summaries by Google. So if I ask it to look up a site, it actually comes up with a summary that's produced by generative AI. Now this is causing problems because it breaks the economic model for the web. Why should I put my content on the web if somebody else is going to summarize it and you never come to my site? So this is interesting, even though it's working reasonably well. What you're seeing most recently also is what we call the language model agents. So language models that generate other language models to do specific tasks. Let's move to the next slide. Here's a quick example here. I'm going to skip the next one. GPT-4 was used to kind of hack into cybersecurity. But what's interesting about it is this was a machine that produces sub-agent. So the planning agent uses GPT-4, but then produces all these sub-agents, which are specialized small language models that say, go after this hack, go after this problem, go after this problem. They were they were much more effective in discovering known vulnerabilities or problems, but they were even more effective with what's called zero-day. Zero-day vulnerability means there's a problem in your system, you don't know it exists, it might sit there for a year or two, and then you discovered it. And when you discover it, you call that zero-day. They were about 550% more efficient than a single large language model in finding these new vulnerabilities. Doing it manually or with a regular model is much slower. We're going to skip this slide because we don't have time. No, skip. Next slide. Yeah. So very quickly, let's wrap up. Hopefully this thing is going to One of the things I want to leave you with is these LLMs, Google likes to call it hallucinations. I like to call it errors, because these things don't think. They don't have a purpose. They don't understand what they're saying. They make errors, and the errors are how they work. You can't avoid them making errors. This is part of how it's defined. Of course, these errors bring in the need for responsible AI. It could be a reputational cost, which is a market problem. It could be a legal cost issue if you do things that the law does not allow. And it could be, of course, societal if you do things that harm society. We have a whole approach here. I'm going to skip through the next few slides on how to deal with it. We've been working on this, trying to define what responsible AI curriculum should be. I'm going to skip this. We built a group, a board, an ethics board of international experts on ethics to help companies address issues. This is a public case study in Verizon. It's in the slides, so you can look at it if you're interested in it and our methodology for doing responsible AI. I'm going to skip this and this. Okay, so conclusions, and then we'll go to questions. What does this all mean? Well, the questions you need to ask is, are you capturing the right data? And what I'll tell you is 99% of companies out there, 99.99%, are not capturing the right data. Every AI project we do turns into a data project first, without exception. Do you know where to use predictive AI versus generative AI? Generative AI is not for everything. Predictive AI is much bigger in applications, if you remember what I said before. How do you train and retain the right talent? And this is the big problem and the big opportunity. So at the university, at the institute, we ended up building multi-levels of training, all the way from AI literacy and awareness. What is AI? What is data? To AI business usage. How do I use it as a business person? To technical usage, to technical expertise, to executives and leaders, etc. For B, C, and D, we believe the best way, and this is important to my message to you, the best way to do it is what we call experiential learning, which means it's not just lectures, it's not videos you watch. You have to implement the technology on your current job. So you see how you do it today, and you see how the technology could do it. And if you do that, then that knowledge sticks and becomes very relevant. And this is what's needed here in upskilling a lot of existing employees to use AI. With that, next slide, please. Oops, okay. I guess we skipped one slide. This is a summary of all the lessons, the secrets. The last one, of course, is talent and culture. And the way to change culture is through training and education. And talent is what's missing today. So with that, I'll go to my last slides. Generative AI offers ways of accelerating work, not automating it. It can reduce robotic, repetitive work that shouldn't be done by humans. It can be a game changer for efficiency. It's a very competitive market, so if you don't do it, your competition will actually create a huge gap between you and them. And if you do it correctly, you can avoid all these extra costs. You don't need billions of dollars or millions of dollars. For a few $1,000s, you can do some very powerful applications. No data, no working AI, and human intervention is a must. In fact, it's a very big positive. And if you don't think about it, and you think you're writing algorithms that work by themselves, you will probably not succeed. So with that, what are the economic opportunities here, say for Tunisia or for North Africa? Well, this is a new area. It is not well understood by the world. There's not enough workers who understand how to use the technology. So the training, and especially practical training on how to use the technology, how to embed it in business, will probably create a huge opportunity. Now, we can wait and have the likes of India or Vietnam or other parts of the world take it over, or we could take advantage of the opportunity and say, okay, what if we produced that talent? What if we created these training programs and did them very well, practical ones, not university level. This is really about making the technology work as opposed to building new technology. And of course, there's a huge business model in giving the services. There's a shortage of labor that understands AI. So if you can produce people who have the training, you can create a huge opportunity. So with that, I have some slides on how to get our newsletter and things like that. And the last slide has my contact information. Yep. And with that, thank you for listening. And we're leaving some time for questions and answers, hopefully. Hopefully I said some things that are interesting. Thank you.
Thank you, Mr. Fayyad, for this rich keynote. Deux petites questions. Et on essaie d'être bref.
Thank you so much. Hello.
Hello.
So my name is Manel. I am a Tunisian student with a degree from the US.
Can you hold the microphone?
Okay, can you listen to me now? Okay, so I had the chance to work before at Google. I can tell that AI is not here to replace any job. It's just here to optimize the task that we are doing. But my question here is, do you think that AI, or let me say, generative AI can replace or is a threat for human creativity and innovation? What I do mean here is, if I want to put a catchy title for an article, and as you have said, I use generative AI for that. If I wanna build an article, I do that. Presentation, I do that. In a way, I do not even spend a second to rely on my own creativity and innovation. So, small question: do you think that AI can replace one day, or is a threat on the long term for my creativity and my innovative mind? Thank you so much.
I think it will not replace. So by the way, the current technology, now when you ask AI of the future, maybe. But if we look at the current technology today, how generative AI works, the autocomplete essentially, the answer is no. Because all it can do is effectively summarize and repeat what it has seen before. Does it replace work? Well, what happens is it accelerates work. So for example, if you look at graphic arts or advertising or any of these, at first people were upset that, anybody can generate all these images and edit very quickly. But in reality, the creativity, the new ideas, all of that were enabled. Because you don't have to spend your time, instead of spending 6 hours producing an image, you can get the image quickly and then say, no, this is not what I was thinking, or I need to modify it in this way. The understanding of what the art is trying to say, of what the creative output is about, whether it's a new creative marketing message or whether it's a new idea, these machines are not capable of doing it at all. So what I think will happen here is acceleration. You can generate many more ideas. You can try out many more things that before were very, very expensive to do. I usually use the example of accounting. Accounting of 60 years ago, what did you have to know to be a good accountant? You had to have a good handwriting. You had to have good addition skills in your head. You had to have a lot of patience. If you made an error, it might take you weeks or months to fix the error in the books. All of that got automated, right? We have software packages that understand IFRS and GAAP. However, do we have less accountants or more accountants than we did 60 years ago? And the answer is, we have more accountants today than in the history of human civilization. Why? Because the technology democratized the function. Accounting became much more relevant to small groups, to small companies, to departments. In the old days, it used to be only established companies could do it. So that's, I think, what's going to happen with a lot of the creative industries. We'll produce a lot more output. So the challenge is going to be, do we have enough time to consume all that output? That's a bigger question. But I don't think it will replace people.
Thank you.
Merci. Thank you very much. This was really, really, really interesting. You told us that one of the risks is the biases that AI can create, etc. So my first question is, how can we avoid these biases, mainly when it comes to impacting the image that Africa have in the world, for example, or Tunisia have? What are the keys in order to avoid these biases? This is the first. My second question is about, I forget it. Please respond the first one, and I will come back to it.
So the biases are very important. So one of the reasons, for example, you get these unintended biases. Sometimes they're intended, right? If you build a product and you only feed it data about how, Western European white males use it, right? You're going to get all these biases against women, against people from other parts of the world, against people from the global south. Even though you don't mean to have those biases, the way to fix it is to make the data more available and to make it easier to train on that data. So for example, I don't know if you know this, but during the coronavirus pandemic, it became very popular to use these pulse oximeters. You put them on your finger, they measure how much oxygen is in your blood, right? This was produced by the billions, and many people were using it. But as an example of a bias here, the whole thing was tuned using white people's skin. So if your skin is darker or black, those oximeters do not work as well, right? Now, the manufacturers didn't mean this, but they just didn't have access to data and they didn't think about it. So this is why for responsible AI, it's important to sit down and have a strategy. How do you assess the risks? What are the things that you might do? How do you conduct audits? All of this is not well understood by anyone. In fact, as a university, we wanted to build a curriculum for teaching it, and we found that we don't know how to teach it. So we had to create a practice where we work with many companies to actually address these problems and then evolve the teaching curriculum and the principles based on that. Yeah.
Thank you. Donc, the last question.
Thank you. So, 𝒂𝙗𝒏𝙙 𝙩𝒉𝙚 from École nationale d'ingénieurs de Tunis. So, I liked your idea about training people on using language models. So, can you explain more how we can do it as a university?
Yeah. Thank you. So, using these, it's very much like the IT skills, right? What does somebody in IT train on? They train on all the different systems. Why is it that the video wasn't playing on the presentation? Why was there a huge delay to this? All of these are little issues. They're not deep, but they're about using the technology correctly. So for generative AI in particular, no one quite understands it. You see a lot of these impressive demos, and I call it deceiving demos, because you see something in demo mode and it works great. You try to use it in a real business context, it becomes very frustrating to the users. It doesn't do what you expect. Google was very famous for getting it wrong now 3 times. Their first chat, Bard, didn't work well. Their second attempt also had problems. And the third one with the search summaries would produce things that say, okay, here is why eating sand is useful to you, and here's how the best recipe for taking poison. Things like that got them in trouble. Again, the demos, when Google launched it, looked amazing, right? This thing can answer questions, etc. So that's why you need a workforce that understands the limitations. So if you have somebody that knows how to train these models, not how to build the models, but how to train them, how to fine-tune them, how to change the prompts, how to create the templates. Most of, like customer service, most of the work is really filling out a template, and you know what the template is. But if you try to do it conversationally, it's very frustrating. This is why I'd rather use a travel site and fill out a template than have a conversation with a computer about my trip, because it will get 90% of the things wrong. That knowledge of how to encode it correctly, how to use it correctly, and an understanding of the limitations. Hey, when I use the machine to train it this way, it will have these other limitations. That knowledge doesn't exist at scale. We don't have talent that understands whether it's engineering or just general usage talent that understands the limitations. So if you understand the limitations, you can have a workforce that's very relevant. The other part is the training. I mean, we're doing training at the Institute, but think about training for all of Africa, training for all of the Middle East. That can be done as a huge economic opportunity that very few people are going to compete with you on. And then the trained labor becomes in very high demand by the whole world because there's not enough people who understand how to do the work. So a lot of it is very basic kind of skills training, not necessarily theoretical or higher education training. Yeah.
Thank you, Mr. Fayyad, for this rich keynote. We are pleased to have you among our speakers. We move to the next panel.
Thank you.